Hi, in this lesson we're going to look at an introduction to electronic principles. So computers, like many other devices, run off of electricity. In this lesson we're going to take a look at the basic principles and formulas that govern electric circuits. By using these formulas along with physical circuits, we can calculate values that are needed to create circuits without having to actually guess at the numbers. So Ohm's law is one of the most basic principles of electricity. In short, it states that the current through a circuit is directly proportional to the voltage across 2 points. In its most basic form, Ohm's law states that the current is equal to the voltage divided by the resistance. You may also see Ohm's law written in different forms. This is the same as the previous form that we saw, just solved for voltage instead of resistance. So we can see that voltage is equal to the current times the resistance. Or we can say that the resistance is equal to the voltage divided by the current. So let's take a look at Ohm's law in action. So given a basic circuit, what would the current be if the resistor is 1000 ohms and the 3-volt power supply is used? So the current is equal to the voltage divided by the resistance. So 3 divided by 1000, which equals 3 microamps, or 3 thousandths of an amp. When we turn our circuit on, we can see that the multimeter reads 3 microamps. Let's try another one. If we are given a current of 15 microamps and a voltage of 3 volts, what is the resistance in the circuit? Using one of the other forms of Ohm's law, we find that resistance is equal to voltage over current. So if we plug in our numbers, we have 3 volts divided by 15 microamps, or 0.015. When we do that math, we find that the resistance is equal to 200 ohms. While Ohm's law is one of the most important electrical laws, there are 2 different laws that we are also going to take a look at. The first of these is power. Power is a transfer of energy into the circuit. For example, a battery may transfer power to a motor. Power is measured in watts. For example, a 100-watt light bulb is converting electricity into a set amount of work in the form of light being given off. Here's an example. When looking at this in action, you can see that doubling the size of the power supply provides more current through the circuit, which creates more power to the motor, causing the motor to turn roughly twice the speed. It may be hard to read there, but the motor on the left is turning about 716 revolutions per minute, and the motor on the right is about double that at 1429 revolutions per minute. The last electrical principle that we are going to look at is electrical energy. Electrical energy is the electrical power over time. Typically, we see electrical energy as kilowatt hours. Electrical energy typically represents the amount of energy put into a circuit. For example, if a light bulb uses 100 watts or 0.1 kilowatts for 1 hour, the electrical energy consumed by the light bulb would be 0.1 kilowatt hours. A 100-watt light bulb that is on for 10 hours would consume 10 times 0.1 or 1 kilowatt hour. Now it's your turn to explore. We're going to take some time to explore this in Tinkercad and then also do some calculations.